Hello friends, in today's question, two small particles of equal mass start moving in opposite direction from point A in the horizontal circular orbit. Their tangential velocities are v and 2v respectively as shown in the figure. Between collisions, the particles move with a constant speed. After making how many elastic collisions other than at A, these two particles will again reach point A. This is a circular orbit and initial point is given as A. V and 2v are their respective velocities, tangential velocities of the two particles. And we have to find out, as they are moving in opposite direction, how many collisions they are going to make along this orbit before once again meeting at point A. So let us consider that let r be the radius of the orbit. You can say let r is the radius of the orbit. And second, at time t is equal to 0, the two particles start to move, from point A. With the velocities v and 2v. With velocities v and 2v. So in this case, what we do, we assume another point B along the circle. So this is our point A, and we assume another point B in this circle where they are going to meet with each other. Say at time t is equal to t1, the two particles again meet at B. So this is point B, and t is the time one of the particle is moving in this direction, and for time it is going to reach, suppose, in time t1, and another one is moving in this direction. It is also taking time t1 to meet at point B. Therefore we can say distance traveled by the particles will be v into t1 and v into twice v into t1 will be v into t1 and twice v into t1. And from here also we can say that the total distance will be covered by both the particles will be equal to 2 pi r, because from A to B in this direction the distance will be vt1, and from right side the distance will be 2v t1. and the total circumference of the circle is 2 pi r. So we can say total distance covered by both particles will be, you can say, Vt1 plus twice Vt1 is equal to 2 pi r. Now from here we can find out value of T1. We can say that T1 is equal to 2 pi r divided by 3v. Therefore, we can find out the distance of each particle. We can say, therefore, distance covered by the particle will be, we can use value of T1 in this equation, it is Vt1. So we can say will be for particle with velocity v, the distance covered will be equal to Vt1. Vt1 is 2 pi r divided by 3v, and v and v cancels out, so this we get, it will be coming as 2 pi by 3. And for the particle with velocity twice v, we get twice Vt1, which is equal to twice v multiplied by 2 pi r divided by 3v, and v cancel out, so in this case we get as 4 pi r divided by 3. So distance covered by particle v is 2 pi r divided by 3, and the particle with the velocity 2v is equal to 4 pi r by 3. So we can say for particle which started from A and reached point B, and in this direction the velocity is v, in this direction velocity is 2v. So this distance is our 2 pi r by 3, and this distance is our 4 pi r by 3. Now it is also given that the collision is elastic collision. Okay. So it is given that the particles make elastic collisions. So which basically means that they are going to interchange the velocities. Therefore, the particles will interchange the velocities. So if they are going to interchange the velocities, so initially the particle which was having v velocity, now its velocity will be 2v. Here we can say for particle with velocity v, its new velocity will be 2v, and for particle with velocity 2v, its new velocity will be v. So in this condition, let us assume that, so this was point A, now this is point B, and at point B the velocities have been interchanged. So in this direction we are going to have 2v, and in this direction we are going to have v. Now let us assume that once again they meet at a point C after time t2. Suppose the particles now meet at point C after time t2. So once again we can use the same concept. The total distance will be covered will be also equal to 2 pi r, so it will be vt2 plus 2vt2, which is equal to 2 pi r, and so similarly we are going to get the same value of t2. Therefore total distance covered by both particles will be, we can say this way, twice vt2 plus vt2 is equal to 2 pi r, and here also we get t2 is equal to 2 pi r by 3v. Now in this case also you can say that the distance covered therefore distance covered by the particles will be, for v velocity we are going to have vt2, which will be once again equal to v 2 pi r upon 3v. V and v cancels out, this will be equal to 2 pi upon 3, and for 2v velocity this will equal to twice v2, which will equal to twice v 2 pi r upon 3b. V and v cancel out, so we get this as 4 pi r by 3. Therefore in this case we can say that this is point C, so distance covered by v, this distance will be equal to 4 pi by 3, and this distance, sorry, I think, let me check, sorry, it is 2 pi by 3, and this distance point C will be somewhere here because this is longer one, so this distance will be coming as 4 pi by 3. From here we can say that for velocity, the distances covered for the respective velocities will be equal to 2 pi by 3. From here we can say the distance covered for the respective velocities that is v and 2v is same. Therefore, from point you can say C, once again there will be elastic collision, and in case of elastic collision, once again the velocities of both the particle is going to interchange. You can say at point C, due to elastic collision, once again the velocities of both particles will interchange. Therefore, we can say it will be back to their original velocity. That is, they will have same velocities with which they started from point A. They started from point A. Okay. So once again they have the same velocity which they started from point A. Or we can say that they have same velocity, the distance covered by them will be same which they covered in time t1. Therefore, distance covered by the respective particles will be same as they did in time t1. So therefore we can say that the respective distances covered by v and 2v will be same. Therefore, respective distance covered by the particles will be same, and by same we mean will be same, that is we have the distances as 2 pi by r by 3 and 4 pi r by 3. So under this condition, and it is asked that after how many elastic collisions other than A. Okay. So we can say that the objects before reaching once again point A collided at two places, point B and point C. Okay. And here we can say, therefore, Therefore, before again reaching point A, the particles collide at two places. From here we can see at point B and at point C. So therefore the number of collisions total collisions are 2. Okay. So we have the option number C is the correct option. From here we can say, therefore option C is the correct option. So this completes the question. Thank you.